working together here. So we just have these two examples here, and that we'll be working on today. So if at any point something doesn't make sense, please do let me know. All right, so I want to remind you that a quadratic in standard form is right here. This is what we've been working with for the entire, basically, the end of chapter 5 and all of chapter 6 is a quadratic in standard form. Y equals ax squared plus bx plus c. Notice the quadratics in descending order. We got the a, the b, and the c like we have been using this whole time. So nothing's really changed from that perspective. What I wanted to do is graph the most basic quadratic function that some books will refer to as the parent quadratic function. This is the most basic example of a quadratic you could graph. And to do this, we're just going to plot a couple of points. We're going to talk about the shape a little bit, and we'll talk about a better method for our two examples. Okay? So if you were going to plot some points, like if you were going to go input, output with x's and get some y's out, what are some really nice, easy, smart numbers to plug in for x? 0 is always smart.
1 and 2.
1, I agree. 2 and 3 I think are also really good. So I'll do it like this. We'll go 0, 1, and 2. But I think you're going to find that if that's all you plugged in, it might not be quite good enough. So why don't we plug a couple more points
5.
in? No?
-1.
-1 and -2.
Okay.
We want to get a couple of negative inputs in there. That'll help us see the shape of this graph a little bit better. So let's use y equals x squared to come up with our outputs. And so if x is 0, wouldn't y equal 0 squared?
Yeah.
And what's 0 squared, Alec?
I have a question for the x on a test. Would we have to put like -2, -1, 0, 1, 2 on like the x?
We'll put all those in for x.
No, like in order.
The order doesn't really matter all that much. I just kind of went in the order you guys mentioned them, but the order doesn't particularly matter. They're going to end up where they're going to end up. Good question. Okay, so if we do plug in a 0, what do we get out for y? 0. All right, so our first point is going to be 0, 0. That's right about there. So far, it didn't look all that special. If I were to plug in a 1, that would be y equals 1 squared. And, of course, 1 squared is 1. So my next point would be 1, 1. So if that's 1, there's 1, 1. Again, so far not looking that special. If you stopped right here, it would kind of look like a line, wouldn't it? I think we're going to find that it doesn't quite look like a line eventually. If I plugged in a 2, it'd be y equals 2 squared. And, of course, 2 squared is 4. So my next point is going to be 2, 1, 2, 3, 4. Huh. That looks a little bit different, doesn't it? Do you see how it's starting to bend somewhat? Do you see how it's not straight? It's not a straight line. If you can't quite see it yet, you'll see it in a second when you plug in these negatives. What if I plug in -1? -1 in parentheses squared is really 1. Yeah. So my next point, this is where it really goes different than what we're used to. -1, 1 is right there. This is definitely not a line, right? Clearly not a line. And then lastly, you plug in the -2, you get y equals -2 in parentheses squared, which is 4. So we end up with -2, 4. Huh. Can you see how there is a lot of symmetry to this? But it is definitely not a line. We only have 5 points plotted here. If I were to do my best to plot a bunch of other points and connect them all, I'll do my best to draw this right the first time. We'd end up with something like this. I think that's a pretty decent representation. Have you guys ever, now the temptation is to like really make it a sharp turnaround, but it should be a smooth turnaround like that. Have you guys ever seen this before?
Yes.
So off to the right there it says the name for the graph of a quadratic is. Does anybody know the name of this?
It's not. I think
You all are going to learn something brand new. This is lovely. Here's the name of that graph. Parabola is the way you say that. Parabola. Parabola.
How do you say that?
parabola. So you put emphasis on the second A. So it's not a parabola.
That's
Parabola
what I
sounds
thought
like
it
some
was.
sort of disease from
Yeah.
East Africa, where it's kind of like the Ebola virus or something. It's not the Ebola virus. This is parabola.
Parabola.
Question.
Is it like a straight line thing? Like if you put like a straight line and can't touch 2 points at the same time?
You're talking about a function, the vertical line test. I think we talked about that in the first semester. Yeah, so if you did move a vertical line across this, it would never touch more than 1 point. Yeah, so it is a function. Yep, you're right. Okay. So guys, listen up please. Big takeaway from the first 5 minutes here of our lesson is if you've got a quadratic, so it's y equals something or other x squared, like this. Listen please. Here's your big takeaway. If it's going to be, if the degree is 2, so if it's y equals something or other x squared, then the graph will always be a parabola. The parabolas can do all kinds of things. They can be really tall and skinny. They can kind of be like really wide and sort of fat. They can open up. They can open down. They can actually open left or right as well. So they can take on all different shapes. But if your degree is 2, right? So if it's y equals x squared, then it'll always take on the shape of a parabola. Okay? That's your big takeaway from here. I will say that to graph a parabola plotting points is going to be really slow and perhaps really frustrating. And so I'm going to show you a little bit of a different way of graphing these, okay? I want to point out a couple of other things. Did you guys notice the symmetry to this parabola? Are you guys good with symmetry? Symmetry means that there's like a dividing line where like one half is the same as the other half. What do you guys think the line of symmetry would be, or the axis of symmetry for this one would be? It'd have to be the y-axis, yeah. So if I drew, that's not very good. If I drew, man, I just keep missing. I missed again. We're going to call that not good enough. What is the deal? Why do I keep missing? Glad I can be entertaining. I'm just trying to get it right. I can't seem to get it right. Do you guys see how the line of symmetry, the axis of symmetry is right there on the y-axis? It's frustrating. I thought I could do it.
No,
For some
it was
reason.
good. It was just,
Yeah.
it was good. You got the bottom part right on.
I did bend it over a little bit there. Yeah. Okay, last chance to ask a question before we do 2 examples. Okay, here we go. So the way this is going to work is I am going to show you the best way to do this first example. I don't know. What do I want to do? Let's do... Let's do one. Let's go ahead and do this one. I was going to skip ahead, but I think we'll do this one. Okay. So guys, I'm going to give you a very step-by-step, clear method. Okay? So here we go. Notice the instructions say, for numbers 1 and 2, graph the quadratic and compare it to the parent graph. I'm really focused on graphing the quadratic. And then it wants us to do a couple things. It wants us to list and label the axis of symmetry, what we call the vertex, and 3 points. If you reference back to what we just did, the vertex is the place where the parabola turns around. Kind of that. In the previous one, it would be the bottom point on the parabola. So here's how we do this. I'm gonna give you a couple of ideas here. This first idea actually comes from calculus, like why this works. So I don't know if I'm going to be able to explain adequately for you guys why this works, but we're going to use that to kind of help us get started. First thing I think we should do is we should label our A, B, and our C. What do you guys think the A value is? I'll write it over here. Remember, it's y equals ax squared, Grace is right, plus bx plus c. Do you guys see why Grace is right that a is negative 4?
Yeah.
Okay, so a is negative 4. What's the b value? So it's a 0. And what is the c value? 7. First thing we always want to do, maybe we do this mentally, maybe we do this on paper, but you want to identify your A, your B, and your C. Here's how you find the axis of symmetry. We're going to follow a little formula. The formula is this. X equals negative B over 2 times A. So this little formula is something that we're going to practice this for the next 3 days in a row. So I think you have pretty good odds of remembering this, but this is something you'll want to practice and remember, have memorized. So here's how we do this. Let's plug everything in. The b value is 0. The a value is -4. So what is 0 over -8? Okay, sorry, let me slow down.
How did you get all those things?
Okay, guys, hey, slow down. Let me explain. How did I get all those things? Are you asking about the b and the 2a?
The x equals.
Sure. So this right here, this is a formula that I'm just going to be honest with you. You're going to just need to accept it, because if you were to say, where does that come from, I'd have to teach you calculus. Just being straightforward with you, okay? And so what I want you to understand is, in order to find the axis of symmetry, in order to find the vertex, that's the formula you start with. If you were to say, where does that come from, that's where we'd go to calculus. And so I don't think I'm going to be able to adequately answer that for you right now, okay? And so we start here with this x equals -b over 2a. And then what we're going to do is we're going to take the different a, b, and c that we found here. There's the a, there's the b, there's the c. And we're going to plug them in the appropriate places. So b is 0. So I plug a 0 in for b. Does that make sense?
Wait, why is it a -0?
Well, so the formula is -b over 2a. And what's -0? It's just 0. So it's not really going to make much of a difference. Grace, if b was not 0, it would make a difference, right?
Yeah.
But here it's not going to make much of a difference. I just want to be consistent with what the formula says. And then 2, the a value is -4. So -0 just being 0, what's 0 over 2 times -4?
0.
It's just 0, right? 0 divided into 8 parts is simply just 0. So what this means then, this means that my axis of symmetry, I'll just put axis here. My axis of symmetry is x equals 0. Let's think about this for a second. What kind of a line is x equals 0?
It's a
Oh, is it?
Remember what?
parallel. I mean, parallel line. No. I mean.
Well, you're doing the right motion, but calling it the wrong thing.
Vertical.
It's vertical, right? Yes. And specifically, x equals 0 is, you guys are going to laugh again because I'm going to probably mess this up. I'll do my best. Oh, look at that. Isn't that x equals, oh my goodness. After all that work, I somehow messed it up.
That was kind of.
Let's try that again. You know what? It was kind of funny. Let's try it again. Oh, I did it again. There we go.
That was so good.
So there's x equals 0, right? There's x equals 0. It's the y-axis. That is also my axis of symmetry that's going to split the parabola into 2 perfectly equal halves. Okay?
I hate the word parabola.
Shh.
Sorry.
Not constructive. So, here is a really key point for you guys to get as we move forward. We are supposed to find the axis of symmetry, and I would say, done. There's the axis of symmetry. I put it on my graph. You want to put it there. The next thing we've got to deal with is the vertex. And the vertex is that turnaround point where the parabola has like bottoms out or has a high point depending on how it's oriented. Where do you think the vertex would be in regard to the axis of symmetry? Think for a second.
On the one.
Wouldn't it have to be on the axis of symmetry? If it really is the axis of symmetry, wouldn't the vertex have to be right on it? Okay, so here's what I'm going to do. Here's how I find my vertex. I know for sure then that my vertex, I'll put VTX for vertex. I know for sure that my vertex is going to be 0, comma, something, right? Because the axis of symmetry is x equals 0. So now my vertex has to be on that. So the vertex is going to be 0, comma, something. How do I find the y to go with an x? If I know the x is 0, how do I find the y that corresponds with that? You don't just pick one. Say again? You plug it in. That's right. So we're going to plug it in back to our equation here. So I've got this y equals -4x squared plus 7. So I'm going to use my table that I've worked on so often. And I'm going to say if x is 0, what's y? So you might be able to do this in your head, possibly. If I plug a 0 in for x, what comes out for y?
7.
Wouldn't it just be 0 plus 7? Okay, so that means my vertex is 0, comma, 7. Okay, let me show you. Did you say y7?
No, I
You have -4 times 0, just be 0 plus 7 is 7. So then my vertex would be 0, comma 7, so 1, 2, 3, 4, 5, 6, 7. is right there. Okay, so far I've found the axis of symmetry. I just found the vertex, and I need to find a total of 3 points. So I've already found 1 point, that's the vertex. I got to find the other couple of points. Wonder what I could do here. Could probably plug in a couple of values. What do you think would be some smart values for x that I could use to help me with this? 1 and -1. I agree completely. Why did you pick those?
They're easy.
They are easy. And how do they relate to the axis of symmetry? They're next to it. Isn't the 1 on the right side?
Yeah.
And isn't the -1 on the left side? And so they're just mirror images of each other. I think this is a really good strategy. So let's see if we can use our formula up here. I'll kind of re-highlight it for us. So we can use our formula up here to come up with the other 2 points. So it's going to be y equals -4 times 1 squared plus 7. So order of operations would have us do 1 squared, which is, and then order of operations would have us do -4 times 1, and then plus 7 would give us +3, right? So 1 comma 3 is right there. And here's where you can use a little trick. If you know that the axis of symmetry is really the axis of symmetry, wouldn't the other point have to just be the mirror image of that one? So if you want to, you could say, well, if that output was 3, doesn't this output have to also be 3? And so I can then just come over here and write -1, 3, and you see the parabola starting to take shape. This parabola is interesting. If we fill this one all the way out, the parabola does not open upwards like that other one, like we did at the start. This parabola actually opens down. And if we compare it to that parent graph, the parent graph opened up. This one opens down. Wouldn't you guys agree that this one is quite a bit skinnier than that parent graph when you compare? Quite a bit skinnier. Wasn't the parent graph pretty wide compared to this one? The parent graph being the first one we did.
Oh.
Isn't this one a lot
Yeah.
skinnier than the first one we did?
Yeah.
Okay, so let's talk for a second. Why on earth would this one open down? Does anybody have a guess why this one would open down instead of up? The A value is negative. That's right. So since the lead coefficient is negative, that'll make this parabola open down. If the lead coefficient was positive, it would open up. Fair enough? Okay. And the reason why it's skinny is because the lead coefficient is bigger than 1. It's a 4. That's what makes it so skinny as well. Okay. Let me just show you one brief thing. We're not going to do the whole next one because we're just about out of time. Let me show you one other thing here that'll maybe help you a little bit.
Wait, I don't understand. What was the y? You had y equals?
Well, hey, hang out for 1 second. I'll answer your question for you. It'll just take me 2 seconds, okay? Hey, I wanted to point out one other thing here on our other example. This will maybe help you if you start doing a little bit of practice. What is your A value here? And what's your B value? And your C value? We'll do this one tomorrow. If you start off with that formula, x equals -b over 2a. Remember on that first one we did, the b was 0? Don't feel like you need to rush through this. We'll come back tomorrow and do this one. But here, the b value is not 0. So you'd get -6 over 2 times 3. I just wanted to point out that the axis of symmetry will not always be a 0. Sometimes it'll be something else. So if you start to practice these a little bit, realize the axis of symmetry could be different. We'll practice more tomorrow. Okay? Oh.